Okay, for this bell work, first thing I notice is the parentheses, which tells me that I'm probably going to need to distribute, and we're distributing this -8. So we'll distribute to both terms. So I'll start with -8 times -7x's, which is positive 56x's. And then also -8 times -1, which is positive 8. Now this will equal the other side, which is 56x plus 8. But I think some of you would notice something at this point, and you could be done. But if you didn't notice, then you'd continue with principles of equality. So that's what I'm going to do. I'm going to put the x's on the left, and then the numbers will go on the right side. So I'm going to look through this equation. I see the plus 8 in red there. It's on the x side of things. It doesn't have an x, so I got to zero that out. So I'm going to subtract 8 from both sides. And you'll notice on the right side, I've stacked it with the other constant, the plus 8 right there. So what happens now? I can drop my 56x in red. The 8 minus 8 becomes 0 as we planned. This would equal the 56x in black, which we're going to drop. And then we have 8 minus 8. Now, I need to show this plus 0 because it's the number side of things. So that x term I'm planning to zero out. I'll need that purple 0 there to show that we have some value on the right side. Next, we'll get rid of the 56x in black, so I'm going to subtract 56x from both sides. So for x's, on the left, I got 56 minus 56, which would be 0 x's, and it is okay for that to be 0. The 56x in black zeroes out, and then the purple 0, again, I've dropped that. Now, at any one of these stages, 1, 2, 3 of these, you could have noticed what the solution was, and in this case, it's just infinite solutions. Okay, and why is it infinite solutions? It's because anything times 0 is 0 at this point, or some of you may have noticed up here, 56x plus 8 equals 56x plus 8. It's the same thing on both sides, so automatically, it doesn't matter what you replace x with, it will always be true. The equation will always be true. So you can say infinite solutions. Some people would say all real numbers. It doesn't matter. So we got two objectives today. I can use principles of equality to create zeros and ones with variables and constants to solve equations. So this objective, even though we're in the same unit, this is a little different. And then the second one, I know that some equations can be solved to form a new equation. You can call them formulas if you'd like. It doesn't matter. But yeah, our answer is going to look different now. It's not going to equal just a number. It's probably going to equal some kind of expression, equation, or formula. Last one there is just telling us the mastery quiz is next time. You don't have to copy that down in your objective, but we do want you to know. The mastery quiz will be based off of this section, 1.8, which is called literal equation. But take 30 seconds and finish copying those two objectives down. But what you're going to see is equations that look like this. Again, I would call this a formula. An equation's fine because it does have an equal sign. I'm not going to solve this yet, but I just want to point out what they're going to look like, okay? Now, on the assignment, because this one says to solve for r, on the assignment, if you see, for example, like this one, r, 2 times. So let's say, for example, it said solve, we use a different one, solve for a, okay? So if it said solve for a, but you end up with 2 a's in the equation, what you're going to want to do on the assignment, just skip that. We're not going to go over that kind of stuff today. Perhaps later in the year we will, but right now we're not. So if you saw something like this, like 5a plus 3, well, we'll do ma, I guess, equals, doesn't matter, -8p. If you saw something like this and it said solve for a, but you have 2 a's in the equation, just skip that problem, okay? So you just say, see the solution. Don't worry about what it says because, again, I'm not worried about going over how to solve these yet. But just understand we expect you to skip these, okay? But if it says something like this, solve for r, there's only one of those variables in here. That's good. We can solve those. So what is a solution? A solution is a value you can replace the variable with that will make the equation true. But now we're going to see that you can replace the variable with formulas or expressions, which are not just individual values. So that's the main difference today. The answers, and this may seem weird for now, the answers are not going to be just individual numbers. It's going to look like an expression, okay? So expect that to happen. And yes, as usual, we will be using principles of equality. We use addition and subtraction principles of equality to make zeros. We also use these principles of equality if we see addition or subtraction in the problem, right? So if we see addition and subtraction in the problem, automatically we would know that we need to make zeros. But the difference is, and it's just like we saw in the bell work, we may have to make zeros out of x terms or just variable terms. So expect that to happen, but we'll know we need addition or subtraction if we see addition or subtraction in the problem. If we see multiplication or division, and you'll have to remember that multiplication is not always shown, it's the only operation that is not always shown, but we're going to use multiplication or division principles of equality to make ones. Now, it's not just the coefficient that may become 1 in today's lesson. So I'm not going to type in here that we're going to do it with just coefficients. No, it may happen with just factors that are in the problem. So expect that. So today, yeah, we shouldn't expect to see any distribution or combining like terms. We may see parentheses on the problems, but we're not going to do distribution because we're not really concerned about that right now. You may end up doing that in the future, but not in today's lesson, since we're just kind of being introduced to these literal equations. Now, another note on making ones is, like I was saying before, you may have to take an expression like, let's say this one, 3x plus 8, and you may have to make it a 1. Okay, like if it said, if we had something like this and it equaled something else, what you'd end up having to do is you'll have to show divide both sides by 3x plus 8, okay, because that would force that to become a positive 1. So you can divide expressions by themselves. Anything divided by itself is a 1, and we'll have to remember that on this assignment. Also, in the past, what we've done is usually make zeros and then ones. In today's lesson, sometimes every once in a while, you may have to make a 1 and then a 0. So keep that in mind. But this idea right here, it may be very new to you, but we're going to see how to use it and when to use it. So solving equations, again, we're skipping distribution and combining like terms. We shouldn't have to worry about that. But we will be using principles of equality. Again, it's not necessarily in this order anymore. So 4 zeros, 4 ones. Again, sometimes we may have to do these in reverse order. So we don't need to number these. But in the end, what we do want is a coefficient of the variable we're solving for to be a 1. So here's that example we saw. It does say up here, go ahead and solve for r. No problem. I found r right there. Now this is going to take some thinking, right? So we got to look at this and think, what do I want out of this? Well, since I'm solving for r, what I'd like is for my final answer to be 1r. And in fact, the coefficient of r right now is a 1 right now. So if I can just take that and drop it, then I'll be done with the problem, right? Which means that I've got this negative 8j with the 1r. It's being added. Since I see addition with the negative 8j, I'm expecting to use either addition or subtraction principles of equality. So with that, I take that negative 8j, I'm going to zero it out with the addition principle of equality, which means if I do it to one side, I got to do it to the other side. Now, this on the right side, let's just focus here. I got m plus 8j, right? I cannot combine these, which is why I've kind of offset the plus 8j. I haven't stacked it right underneath the m, so I know I can't combine these. You can't combine these because they are not like terms that you can combine them. So don't combine them. Keep them separated, and when you keep them separated, it will drop as just, we can just drop the m, and then you'd have that plus 8j, right? Well, what about the negative 8j on the left? That's zeroed out, just as we planned. Okay, so this right here, we have 1r equals m plus 8j. It's 1r. Okay, so that's what it was pretty much asking for in the beginning. And if you wanted to see that 1, you could put it there. It was there the whole time, you just couldn't see it was a phantom 1. But this is our solution. And if you went into the equation and you said, I'm going to replace r with m plus 8j, you'd get the negative 8j and the positive 8j to zero out, and you'd get m equals m. That's a true statement. And you'll see that it's going to be true on all of them. I'm not going to go through the checking of these, but as long as you're doing your principles of equality, you should be in good shape, okay? So yeah, you probably noticed the answers look very new to us, and that's okay. So for this one, it says, go ahead and solve for A. No problem. So in solving for A, what do I notice? I see I've got the A, and then I've got the plus X. In fact, that right now it's actually 1A. So we're halfway to our solution, and when I do a principle of equality here, I will in fact have 1A just by itself. So it's only going to require one principle of equality to solve this. And what is that? Well, it means that that plus X, I got to zero it out. So I'm going to subtract X from the right, which will zero that out. But if I do it to the right, I got to do it to the left as well. So what I end up with here, again, I've offset the negative X from the 10 because they're not like terms that I can combine. So I don't want to stack them directly. But now I've got negative X, and I've got the 10, but it's a positive 10. So I got to show that as plus 10. Now this is the way that I have this equation written. You could, if you wanted to, write it as positive 10 and then the negative X. This is not going to make a difference. You could write it like that if you wanted to, and then that still equals 1A. These are the same solution. I believe the assignment will accept both, so it doesn't really matter which order you put these in, but same solution, just written in a different order, that's it. So we see now, again, that the answer is not an indivisible number, it's an expression. That's okay, and it's a formula, because you can use formulas like this. Any formula you see, you can actually manipulate for a specific variable. So if you saw, like last time, right, with rectangles and triangles, you could manipulate those formulas for either length or width or base or height, and you could solve for those specific variables. Yeah, when you put this into the assignment, what it'll do is it'll have a box right here. But, you know, either one, right? But this equals 1A, this equals 1A. I'm putting 1A, but yeah, most students actually choose to just kind of not show the 1. And it doesn't matter, right? But yeah, the only thing you're going to do on the assignment today is just fill in this box with either one of these. Yeah, you wouldn't have to worry about that. Now, since I'm writing these, I'm keeping the 1s on there just so we know that we need that coefficient to be a 1. But even then, you don't have to. So we've seen from the last two problems, the addition principle of equality and then the subtraction principle of equality. Now, let's do another principle of equality. So for this one, we have up here, it says, go ahead and solve for G. Yeah, no problem. I found the G, but again, what is happening to that G? Well, right now it's being multiplied by 5. I don't want it multiplied by 5. What I would like is just 1G, right? So all I'm really looking to do at this point is to change the 5 into a 1. So how do you change a 5 into a 1? Well, you may have noticed that it didn't show the operation, so we know it's multiplication. That means that I should know I'm going to change it into 1, by the way, but I'm going to use either the multiplication or division principles of equality. To make a 1 from a 5, I'm just going to divide it by 5. Now you notice here I'm actually showing the division a little different. That's because we're probably going to end up with a fraction, because on the left side, if I take the h and divide it by 5, because remember I had to divide by 5 on both sides, it's better to show this answer as h divided by 5. Okay, so this ends up being our solution. And yeah, again, the 1G, the 1 is not really necessary, but in the assignment, you just have to type in h divided by 5, and then you should get full credit there. Well, there's our third principle of equality. We saw addition, subtraction, and there's division principles of equality. So yeah, on this one, we're kind of expecting to use some multiplication principles of equality. Now again, how can we know that from the beginning? It's because it's a divided by 5. Since it's using division, I know I will have to use either division or multiplication to make this a 1A, which is what I do want. So I'm going to take this, and what I really want from this is 1A, not a divided by 5. So that divide by 5, how do I make it a 1? Well, same way we've been doing it, like we saw a problem like this on the mastery quiz, the last mastery quiz. Just multiply both sides by 5. Now, the reason why this is a 1 is from fraction multiplication, which I'm not going to get into. But this right here that I've crossed this out, that's a 1 right there. It's just slanted. But that becomes 1A, which is what we do want. Then on the left side, I can't really do anything with 5 times z other than to just show it's 5z. And actually that's, again, that finishes the problem because I have solved for A, which it told us to do, but it's 1A, which is what we want as well. So that's all 4 principles of equality, which now that we've seen them, we can use them. we can use them anytime. We know we can use them anytime. So this one looks a little different, and I think for the most part, students see the parentheses and it's like, I got to do some distribution. Again, the expectation from this assignment is that you should require no distribution. Okay, so what's going on here? It says up here to solve for x, here is my x. X is being multiplied by this set of parentheses. Okay, so this set of parentheses, I really don't care what's on the inside. It's kind of like saying you got a coefficient of x right there. So since I am going to treat it like a coefficient, it's something being multiplied by the letter. I'm going to take it, and what I'm going to do is make it a 1x. Okay, because if I can make it a 1x, then I know that I have found the solution. So how do you take an expression d minus 19, in this example, to become a 1? Well, like I showed a few slides ago, is I can actually take that full left side and divide it by the same. I'm going to keep it the same, d minus 19. I'm keeping the parentheses, although it wouldn't necessarily be required. Okay, now, again, it is a principle of equality, so if I do it to one side, I do need to make sure that I do it to the other side as well. And notice I've done it to the full side of w. Okay, well, what happens? Well, here you got d minus 19 divided by d minus 19. That, in fact, is 1. There's my 1 right there. I've accomplished that, but what do we get that this equals? I can't combine any of that garbage. So my final answer just ends up being w divided by d minus 19. Now that's fine, especially doing it by hand, but how are you going to type this into the calculator? Well, when you go to the calculator, of course, you would type w first, and then to get that fraction line, you're going to type the slash button in, which is also the question mark, I believe. And then it's likely that I think you're going to have to push the down button to get into the denominator. And then you can you're going to have to open up a set of parentheses here. So when you type this denominator into the parentheses, you'll probably have to use into the denominator, d minus 19. When you type that into the denominator, you'll probably have to use parentheses. I can't guarantee that you will or that you should, but I believe that you will. So parentheses, and then we got the denominator, right? So you type in a d, and then minus, then you'll type in 19, and then you just close that with parentheses, and then you can push enter on the computer, and then it should tell you that that answer is correct. Okay, so it's possible this is how you're going to type it in, almost like you would on the calculator, but it's possible also that the parentheses won't be necessary, but if you do type them in, it should still give you full credit. So this problem, it may have looked like we're going to need maybe 2 principles of equality. There's only 1 because we wanted that coefficient of x to be a 1, and that's what we did. But do expect there to be some problems that are going to require 2 principles of equality. This one says to solve for f. If it wanted us to solve for either m or n, then it would take 2 principles of equality, but it's just f. And what do I notice about f right here? It's being divided by t, right? So since I've got division, I'm expecting either division or multiplication principles of equality. So it will be a principle of equality, but how do I make that divide by t instead a 1f? Well, same way that we did that problem a couple problems ago, is to make divide by t a 1, I'm just going to multiply both sides by t. Now on the left, I've got to put this in parentheses because it's not just t times the 3m, it's t times the whole side right here. So that's actually going to be my final answer right there. I have t parentheses 3m minus 5n, capital N. Yeah, it says that up there at the top, if you have capitals and lowercase letters, you need to remember that on the assignment, because if you, like this n, which is capitalized, if you typed it in as lowercase n, it would mark it incorrect. But that does it right there, because over here, that would be like t divided by t, which is 1. And so we have actually found the solution. Okay, now I'll mention this again. If you see a problem on the assignment, like this one says solve for a, if I saw 2 a's in the equation, I would automatically just know to skip that one, because we're not going over that crap today. But for this one, we have a right here. I see it's multiplied by m and negative 14. So I'm expecting multiplication or division principles of equality. And that will then make this a 1a. So I got negative 14 and an m, which I can actually just make this directly a 1 by simply dividing that by negative 14m. Now you can look at these as separate, right? You could say, well, I'm going to divide by negative 14 and then divide by m. but I think it's better to show this in one step. It's just if you do it to one side, don't forget to do it to the other side. So negative 14 is, negative 14 divided by negative 14 is 1. And then m divided by m is 1. So I'm showing this as two separate multiplications, but the truth is you could show it as 1 if you wanted to. So that is, in fact, 1a, which is what we wanted. And then, well, what does this equal? It equals everything there on the right. So that right there is our final solution. So again, this may seem weird. Again, when you type this into the calculator, into the assignment, you may have to use parentheses around the numerator there and then put in your denominator. But as new as this is, and as strange as it may seem, it's okay to do this. Again, it's just working with formulas to solve for specific variables. So in the future, hopefully you see formulas that are a little bit more applicable. But for now, it's just very random like these ones are. So this one, once again, students may see, because we're so used to this from this unit, just taking the a squared and then multiplying it into the parentheses. We don't need it. It says to solve for b, and even solving for b inside the parentheses, yeah, it doesn't matter that it's being, this quantity here in the parentheses being multiplied by a squared. We don't care about that. But what I do want from this, so I know I'm going to need a principle of equality, right? But what I would like is to take that b minus 9y, and I would like to just be able to take it and drop it, right? Which means that it's the a squared right now that I don't want. Well, why is it that the parentheses is the one that I want to drop? It's because it's the whole parentheses that the b is inside is being multiplied by the a squared. So it's the a squared that I'm going to change to a 1. And so you can show the 1 there, even though I'm going to get rid of it later. How do you make an a squared a 1? It doesn't matter if it has an exponent. It doesn't matter if it's a letter. In order to make anything a 1, just divide it by itself. Now, again, I'm showing the division differently. So it's divide by a squared, but if I do it to one side, I got to do it to the other side. So on the left side now, I've got x divided by a squared, and that's okay. And this is my new expression. X over a squared equals 1 times parentheses b minus 9y. But even at this point, I don't really want that. I don't want the parentheses, so first I'm going to make that a phantom 1, and then I'll get rid of the parentheses. Okay, this allows me to, without the parentheses, usually we can think about this a little bit more clearly. With the parentheses, it can cause some confusion because it gets a little cluttered and ugly. But now, remember, we're solving for b. Well, there's the b. In fact, that's a 1b, which is good. It's the minus 9y that I don't want right there. So I'm going to take this, negative 9y, I'm going to add 9y to both sides. Now again, I'm showing the plus 9y offset from the x over a squared because they're not like terms that I can't even combine. So what happens here? Well, I've got 9y, and then we have the term x over a squared. There's nothing to indicate that that would be negative, so I'm going to show it as a positive x over a squared. The 1b, yes, we get to drop that, and if you like to see the 1, that's fine. But negative 9y plus 9y is 0. So this solves for b. That's the b that we want. But again, if you were to reverse that order and say, well, what if you wanted to write it as x over a squared, and then you'd have positive 9y. Again, it doesn't really matter if you do it like that. It's exactly the same. So there we go. We found our solution in 2 different ways, but they are exactly the same. Yeah, so this one, it required 2 principles of equality. This may have been new for us, making that a squared divided by a squared a 1. But if we see parentheses now, we're going to force that number on the outside of the parentheses. We can force it to become a 1. If it wanted us to solve for a, of course, we would have had to divide both sides by the parentheses, which we've done in a previous problem. But for this one, it's possible, just understand it's possible to make your 1s first now and then 0s with these types of equations or formulas. So this one, let's go ahead and solve for d. There is the d. And so I see I've got the d, it's being multiplied by a, and it's got minus 2q squared. So the first thing I'm going to do actually is make that AD term, I'm going to get it by itself. Okay, so that means I've got to make that negative 2q squared go away. Because right now my goal is to make this AD. Kind of like if it was just a coefficient with d, right? You want to isolate the d's. So even though the coefficient is an a, that's not a problem. I can zero out that 2q squared by adding 2q squared. But if I do it to one side, I've got to do it to the other side as well. Okay, so we already dropped the AD, and negative 2q squared plus 2q squared. That zeroes out as planned. On the left, though, we have the 2q squared, and I have to keep it separated from the m, which is positive, so I got the plus sign. I got to keep these separated because they're not like terms that I can combine. You can't take 2q squared plus m and make it 2q squared m, because it's addition. Making it 2q squared would make m, 2q squared m would make it just multiplication, but it's not. The last thing I need here from this problem is not AD, but I need this to be a 1D equals something, right? So how do I make that a 1? Same way I make a number a 1, I simply take it and divide it by itself. So once again, I'm showing the division differently because if I do it to one side, I have to do it to the whole other side. So we end up with this, again, it's like an expression there. That's okay. We know that's okay to have our answers shown as expressions like we have here. But once again, when you put this into the assignment, it's likely you're going to have to use parentheses here for the numerator. Don't forget that, otherwise you may type it in incorrect and it'll mark it wrong, but it's not that you've done it wrong, you've just typed it in wrong. There's our two objectives. Again, it's just working with literal equations. I can use principles of equality to make zeros and ones with variables and constants to solve equations. And I know that some equations can be solved to form a new equation, which is what we've seen. We've taken a formula and then created a new formula out of that formula for a specific variable.